Hello, I'm Professor Takahiro Wada from Nara Institute of Science and Technology, Japan. The title of the talk is Digital Human Model for Symptom Progression of Vestibular Motion Sickness based on Subjective Vertical Conflict Theory. In level 3 or higher level of automated driving, which is defined as SAJ 3016, a driver becomes a passenger and subtask in the car will be increased. So there is a concern to increase motion sickness. Remind that the original purpose of the automated vehicle is to release the driver from driving operation to reduce workload and increasing the productivity during transportation. Therefore, of course, the motion sickness should be removed. Quantification of motion sickness is indispensable to develop the countermeasure for reducing motion sickness in automated vehicles. So, of course, much effort has been done so far, including the questionnaire and biosignal measurement and the computational models. In this presentation, we focus on computational model. Among the computational models, roughly speaking, we have two kinds. The first one is a fitting model to describe the experimental results, including the ISO standards. And the second one is a model based on the hypothesis or mechanism of motion sickness, meaning that how the motion sickness occurs, including sensory conflict theory and subjective vertical conflict theory. So we focus on the subjective vertical conflict theory, which is the refined version of sensory conflict theory. In subjective vertical conflict theory, the conflict in sensory conflict theory is defined as the discrepancy between the vertical direction sensed by sensory organs and the estimated one by experiences that is formed by an internal model that is thought to be built in the central nervous system. This is a computational model of SVC theory for 6 degrees of freedom head motion. The input of the model is head acceleration and the angular velocity of the head. And the output is MSI, the motion sequence incidence. Due to lack of time, I'm not in detail, but that model includes dynamics of otoliths and the same circular canals, and the robust filter that describe the sensed vertical to sensed verticality calculated from these two. And here is this part described internal model. The 6D SVC model has been used in several researches, and also that is expanded to several directions with vision and with human motion prediction effect. And it is shown that the model accurately predicts the motion sequence observed in experiments, but the output of the model is MSI, which is defined as a percentage of people who would vomit. So, but from engineering point of view, the prediction of individuals rather than the distribution and milder symptom of the motion sickness rather than vomit are desired. Therefore, we propose the model to predict individual symptom progression of motion sickness. This part is same as the 6DO SBC model that the predict the MSI. But the output of the model is changed into the MISC, which is defined as the 11-point Likert scale questionnaire to describe symptom progression. And 4 types of nonlinear dynamics that connect the subjective vertical conflict and the MISC output were introduced. I will explain in the next slide for the detail. This is the detail for the 4 different types of the MISC output part. First one is called MSI base that employs the same structure with original 6-DOE SVC model, but the parameters of this part has been identified to fit the MISC. And the other 3 the output parts employs basically the same structure that combined 2 parallel interacting critically damped second order transfer function with faster and slow dynamics. But to describe the habituation to the motion history, that is used in that is proposed in previous research. However, the pre-scaling part and the post-scaling part are different among methods. In OMA AP, after this pass, the power scaling is employed is here after the two passes, and for OMA BP, the power scaling was introduced in before a pass, and the OMA Hill is in Oman Hill. This same Hill function is employed in scaling part and this scaling part. This slide shows the experimental method. We employed 15 participants, and they were exposed to 4 after motion with a small electric vehicle, as shown in this video. And we also prepared 2 head conditions, including static condition, where the participants were asked looking forward, and in move condition, they were asked to tilt their head by nodding to align the head to the gravity inertial acceleration. And as the evaluation method of motion sequence symptom, MISC were used, and it was reported by boys and every 60 seconds. This table shows the MISC. MISC 0 means no problem, and 1 means some discomfort but no specific symptom, and 10 means vomiting. But due to lack of time, I'm omitting detail. Please see the paper for the MISC. This slide shows the experimental result and the model predicted result for each participant and each head movement condition. This black line denotes the time history of observed MISC in experiment. So as you can see from this figure, symptom progression differs among participants. This participant is rather small MISC, but for this participant, the MISC reached to the 6, right? Again, some symptom progression differs among participants. And model predict MISC was calculated by identifying model parameters or MISC output path for each individual by inputting IMU data attached to the participant's head. And okay, so the result of the model predicted MISC were displayed as colored lines, right? So as you can see from all data, all result, model predicted MISC fits observed result well for all 4 models. This slide shows the mean predicted MISC error for each MISC output path. As you can see from this figure, all 4 accurately describe the observed MISC, but by comparing 4 MISC output parts, Oman Hill and Oman BP are promising, and MSI base is worse among these 4 MISC output parts. This is a conclusion of my talk. The new computational models to predict the individual symptom progression of motion sickness has been developed based on the SVC theory. And all proposed models explain experimentally observed sickness progression. And the future works include the validation with a wider variety of motion paradigms, and also including a variety of factors, including visual information. Thank you very much for your kind attention.